Hey, it's T. I'm one of the geniuses at Ask Zylor. So let's just get started with the live session. Okay, so this first question is from grade 11 function, so it's dealing with the cosine law. So the question is telling me that there's two sides of a parallelogram measuring 7 centimeters and 9 centimeters. The long diagonal is 12 centimeters long. So to calculate the interior angles to the nearest degree, and the second part is telling me how long is the other diagonal and round your answer to the nearest tenth. So let's deal with the first question and draw an example of what the parallelogram is. So each side is 7 and 9 because they told me the two sides. And we have two diagonals. So we have a long one and a short one. So the long I'm going to show with this red line, and the short I'll show with the green line. So they told me what the long one is, so I'm just going to get rid of that. The long is going to be 12 centimeters. Right. So we're going to go and make a triangle with the long diagonal, the 7 centimeters and the 9 centimeters. So we can find what this interior angle is. So if I use the cosine law, the cosine law tells me I have c squared is equal to a squared plus b squared minus 2ab cos of big C. So I'm going to associate 12 with c, and the ab could be either 9 or 7. So then I have 12 squared is equal to 9 squared plus 7 squared minus 2 times 9, 7. And then cos of c is what I'm trying to find, the angle of this. So then when I rearrange, I end up with cos c is equal to 12 squared minus 9 squared minus 7 squared divided by negative 2 times 9 times 7. So we're doing a question from grade 11 functions where we're using the cosine law to evaluate this shape, this parallelogram. So we're trying to find all the interior angles. So I came up with a triangle and I'm trying to find one of the interior angles so I can find the rest of them. So then my C is simply going to be the cos inverse of this entire value. So when that evaluates, I get 96.3 degrees. So this is one of my interior angles. So when I redraw the parallelogram, this is 96.3. That means this is also 96.3. And then I can find these two angles by simply doing, I know the interior angles all add up to 360. So I can do 360 minus 2 times 96.3 and then divide it by 2 to get one individual angle. Right, so this should give me 83.6 degrees. So my interior angles are going to be 83.6 degrees and 96.3 degrees. So the second question is asking me what's the other diagonal. So the diagonal I used was the longer side. Right? The second part of the question is asking me what's the shorter diagonal. So they're asking me what this is. Right. So for this, I'm basically going to set up another triangle with the new angle that I found, 83.6 degrees. And I'm trying to find what this is. I know this is 9, I know this is 7. So once again, I'm going to go ahead and use my cosine equation. I'm going to associate my d with my c value. I'm rewriting the cosine equation. This time I have my angle and I'm trying to find first side. So I'm just going to plug in 7 squared plus 9 squared minus 2 times 9 times 7 times cos 83.6, and all of this will be square rooted. So we're doing a question about using the cosine law to solve this parallelogram to find the diagonal and find the interior angle. So we found the interior angles, and now I'm finding the second diagonal, which is the shorter diagonal. And when I evaluate this, I should get 10.78 centimeters. So this is again a grade 11 functions, a cosine law application question. This deals with displacement. So we're not getting too much in behind the physics of things, we're just getting to the math. So a ship leaves port at 1 p.m. traveling north at a speed of 30 miles per hour. At 3 p.m. the ship adjusts its course and a bearing of north 20 east. So we'll discuss what that is and how far is the ship from the port at 4 p.m. So it leaves at 1 p.m. and it's going north, and it's going north until 3 p.m. So it travels for 2 hours. We know it's going at 30 miles per hour, so just visually, if it's 30 miles per hour, that means for 2 hours it's going to be 60 miles. So I know this is going to be 60. Right? He's going directly north, so it's just a straight line going up. So the next part is saying at 3 p.m. so he's traveled from 1 p.m. to 3 p.m. From 3 p.m. the ship adjusts its course on a bearing of north 20 degrees east. So how I read this is north 20 degrees east. So I start from my north and my east is over here. So what I do is I start from my north pole and I go 20 degrees towards my east pole. So this is 20 degrees. Right? And after they turn 20 degrees north towards east, they keep going for another hour because they stopped at 4 p.m. So we started at 3 p.m. and they stop at 4 p.m. meaning they traveled for another hour, so the speed doesn't change. So they only traveled 30 miles in the second half. Right? So let's go ahead and get rid of everything else that we don't need right now. So this is what we have. They're asking me how far is the ship from the port at 4 p.m. So this is where they started off. So let's say this is the port. They're asking me to find this distance. So I know one side, I know the other side, I'm trying to find the third side. And I can find this angle because I know this is a straight line. So I can find this theta by simply doing 180 minus 20, which is 150. Sorry, that's 160. Right, so I have a triangle and I need to solve that triangle now. So I have this angle is 160 degrees, I have 60 miles on one side, I have 30 miles on the other side. I have to find what this is. So I'm going to use the cosine equation again to solve this. So I have 60 squared plus 30 squared minus 2 times 60 times 30 cos of 160. Let me move this. Right, I'm just applying the cosine equation again. So the next thing I'm going to do is just simplify all my terms and then square root everything. So under the square root I should get 882.89, and then my distance is going to be 88.78 miles. So let's recap what we did. So this dealt with a ship leaving a port and we have to find the displacement. So it said it's going north for 2 hours at 30 miles per hour. So that tells me they traveled for 60 miles. Then they changed direction and traveled for another hour at the same speed. So they traveled for another 30 miles. And they told me that the direction of travel was north 20 degrees east. So I found what the angle was, and I can find an angle inside the triangle that I'm trying to solve because I know that's a straight line. So I used 180 minus 20 to give me 160, and then I employed the cosine equation to find my distance. So this question is a trigonometric optimization question, so this is a grade 12 calculus vectors question. So you get to this stage after going through derivatives and then going through trig derivatives as well. So this question is asking the rectangle ABC is inscribed in the area between the x-axis and the part of the graph y equals cos 4x. So this is my function y equals cos 4x between the x-intercepts. So these are my x-intercepts, and we're basically asked to find the area, maximize the perimeter of this rectangle. So the rectangle is inscribed in the area between x-axis and this part, so we're essentially looking at everything under the graph and above the x-axis. So then what we have to do is determine the maximum perimeter of ABCD and the dimensions of this rectangle of maximum perimeter. So what we should do first is find out what these x-intercepts are, because we need to find a range for my x value. So then I know my x-intercept is when my y is equal to 0, so I have cos 4x, and then cos is going to be 0 when I have negative pi over 2, or I have positive pi over 2. That means my x values are going to be negative pi over 8, and x is equal to positive pi over 8. Right, so these points are going to be pi over 8, and this is going to be negative pi over 8. So my x value is essentially that. So my x can only be greater than 0 or less than pi over 8. So this is the domain I'm trying to use to maximize my perimeter. So let's go ahead and write my equation for my perimeter. So that's going to be I have AB, BC, CD, and DA. In other words, I can have two x's, which is this, and two y's. Right. So I have two x's for each of these. So if this is my length, then I have 4x in total, and this is my, let's say this is my length. My length will be a y, and then I have two of those, so I have 2y. So let me rewrite this. So I have my perimeter, which is equal to length times 2 plus width times 2. And I said my width is, this is my x. Let me redraw this. This is my x, so I need to have two x's for my width alone. So I'm going to put 2x inside my width, and then I said for my length I have 1y, so I'm going to replace length with y. And this is equal to my perimeter. But I don't want two variables, so I'm going to write my y in terms of x. So my equation was y is equal to cos 4x. I'm going to replace that in my perimeter equation. So it's going to equal 2 times cos 4x plus 4x. So this is my equation that I'm trying to optimize. Right. So if I'm trying to optimize this, that means I need to check what my first derivative is. So I have p prime, and then this, the derivative of 2 cos 4x. I'm going to keep 2 on the outside and find the derivative of cos 4x in terms of my x. And then 4x is simply going to be 4, so I'll write that. So I know my derivative of cos is negative. My derivative of cos x is going to be negative sine x. Right? So I'm going to write negative 2 sine 4x. So this is part of the chain rule. So I'm finding the derivative of the outside function, which is cos x. So I changed it to sine. and left the inside function, which is 4x the way it is. And then I have that multiplied by the product of the derivative of the inside, which is 4x. So the derivative of 4x is simply 4. So I'm multiplying by 4. And I still have 4 on the outside from the 4x. Right? So this simplifies to negative 8 sine 4x plus 4. So this is my derivative for my perimeter. So what we're doing is an optimization question revolving around a trigonometric function. So I was given a function of y is equal to cos 4x, and I have to find the maximum perimeter given that the rectangle has to be inscribed between 0 and my x-intercept, which I found was pi over 8. So my x value can only be between 0 and pi over 8. Then I came up with an equation for perimeter, which is 2 cos 4x plus 4x. Then I found the derivative of that, which ended up being negative 8 sine 4x plus 4. Right? The next step is to make that derivative equal to 0 and solve for my x values. Sine 4x plus 4. So then I can bring the 4 over to give me sine 4x is equal to 4 over 8. In other words, that's going to be 1 over 2. And then essentially we're looking at when is sine 1 over 2, when it is pi over 6. All other angles are going to be outside the scope, outside our domain, because if we recall, our domain is when x is bigger than 0 and less than pi over 8. Right? So then x will end up being just pi over 24. There's only one answer. So then what we have to do is go back and plug the endpoints of my domain. So my domain was 0 and less than pi over 8. And I want to plug in what my critical point was, because that's what I found over here, pi over 24. And then pi over 8, which is my other endpoint. So my p at O will be 4 times 0 plus 2 cos 4 times 0 again. So that's going to be left with 2. Then we'll find out pi over 24. 4 times pi over 24 plus 2 cos 4 times pi over 24. This should give you approximately 2.23. And then the other one is pi over 8. So let's do that as well. So we're just plugging in these points. Cos 4 times pi over 8. We're checking my endpoints and my critical point right now to see which is going to give me my absolute max. So then this is approximates to 1.57 as well. So looking at my endpoints, my ends of the domain, I have 2 and 1.7, but my critical point gives me 2.2. That means my perimeter is going to be the maximum when my x is pi over 24. So the next question is from a grade 9 math course. So we asked to find algebraic expressions for each cost. So for each one of these, we're trying to find an expression that tells me what the situation is. So for the first one, it's $4 a pair for skate sharpening. For part B, it's hamburgers at $3 per person, and so on. So let's do part A now. So I'm going to say let x be how many shapes, how many pairs of skates. So X is how many pairs of skates that need sharpening. So to give me an expression for that, I know it's $4 a pair. So that means my cost will be 4 times X. Right? So if I want to get the cost for how many pairs of skates I can get sharpened, it's going to be just 4 times X. And X is how many pairs that need to be sharpened in total. So part B is asking me hamburgers at $3 per person. So I'm going to say X in this case is going to be number of people. So if it's $3 per person, the total cost is going to be 3X. This is telling me that for every person I charge $3. So in total, my expression is just 3X. So C is a little different. C is $2 per hour plus $5 for renting skates. So it's $2 per hour and $5 for skates. So if we look at this word equation, it tells me that it's $2 per hour plus $5 per skate. So the only thing that's changing is how many hours I'm using the skates for, right? So I'm going to introduce a variable that tells me how many hours I have. So I'll say X is number of hours, right? So my cost will be how many hours I'm skating and then the cost of the skates itself. So it's going to be 2 times the number of hours, so it's going to be 2X, right? Because for every hour I'm charged $2, and then I add 5 at the end because that's a fixed cost that applies regardless of how many hours I skate. And then the last one is hats on sale for $10 each. So $10 each. So this tells me the only changing variable is how many hats I'm buying. So I'm going to introduce a variable again saying X is number of hats, and since each one of them is $10, I'm going to say the total cost is 10 times X. So this tells me for each hat I'm paying $10. If I buy 2, it's going to be 20. If it's 3, I'm spending $30. Right, so this is a grade 9 math question that's telling me to write algebraic expressions from these word equations. So I just need to see what's changing in my equation and what's staying the same, and then introduce a variable to describe what's changing. Functions question, which is asking me to maximize the profit. So a company's profit in thousands of dollars on sales of computers is modeled by one function, P of X, where X is thousands of computers sold. The company's profit in thousands of dollars on sales of stereo systems is modeled by another function, where X is thousands of stereo systems sold. So we're asked to find the maximum profit for the business in total. So we have to consider the computers and the stereos. So what we have to do is essentially find the vertex for these functions, right? Because my P of X is telling me my profit, and the other P of X is again telling me my profit. So let's deal with computers first. It's going to be P of X is equal to negative 2x minus 3 squared plus 50. This is already in vertex form, so there's not much else I have to do. So my vertex is going to be 3 and 50, right? But the question, it tells me these are in thousands. So the maximum profit I can get from computers is 50,000, so 50,000. So this is my profit from computers. I also need to find the amount of profit from stereo systems. So my stereo system equation is p of x is equal to negative x minus 2, x minus 7. Right? So this tells me that these are my x-intercepts. So I need to find the exact middle of the x-intercepts. So if I have two x-intercepts that essentially look like this, my midpoint or my vertex is always going to be the same. So it's just the midpoint between the two x-intercepts. So I know my x-intercepts is x is equal to 2 and x is equal to 7. So to find the midpoint, I just need to add them and divide them by 2. And so it's just 7 plus 2 divided by 2 is going to be 9 over 2 or 4.5. So my x at the vertex is at x is equal to 4.5. So this is where my vertex is for my stereo system. So let's go ahead and find the profit. So what I'm going to do is simply plug in 4.5 for every x. So that's negative 4.5 minus 2, 4.5 minus 7. And when I evaluate this, I should get 6.25. So this is the amount of profit I get from my stereo system. So again, this is in thousands, so it's going to be 6250. So I have 6,250 as my profit. So they're asking me what's the maximum profit this business in total can get. So the maximum profit is when I add the two together. So it's going to be 50,000 plus 6,250. Which adds up to 56,250. So let's go ahead and do another calculus question. So this is involving the derivative test. So we're asked to use the first and second derivatives to test and analyze this function so we can sketch it. So the first thing we should do is get the first derivative for this. So it's simply going to be dy over dx is going to be 3x squared minus 6x minus 9. And then I'm going to go ahead and find any critical points from this. So to find it, I can try and factor this. So I make 0 equal to 3x squared minus 6x minus 9. And this gives me 3. I can do this. I can do factoring by grouping. So I have 3x squared plus 2x minus 8x, 6x. Sorry, this becomes 4. So what we're going to do is factor this by looking at factors for 3 times 9, which is 18, and factors for this which add up to negative 6. Right? So this could be negative 6, it could be 9 and 2, it could be 6 and 3. So before we do this, we should be factoring out the common term. So we get x squared minus 2x minus 3, which makes it a lot easier, right? So we can just look at the factors for 3, which end up being x minus 3, x plus 1. So then my x-intercepts are going to be x is equal to 3 and x is equal to negative 1. So these are my critical points, right? So these are the points where it'll be either local max or local min. Now I don't know which one's which, so I can either use the intervals or I can use the second derivatives to verify that. So they asked me to use the first and second derivative, so I'm going to go ahead and use the second derivative to verify which of these are a max, which one of these are min. So my second derivative is going to be, when I take the derivative of 3x squared minus 6x minus 9. In terms of x, so that's going to be when I have 6x minus 6. So I can go ahead and find any inflection points right now. So this is going to be 6x minus 6. So I'm going to make the second derivative equal to 0 and solve for any x values, which gives me 6 over 6, which is just 1. So when x is equal to 1, I have an inflection point. What that means is I'm going to change from concave up to concave down, or I'm going to change from concave down to concave up. Right? So how can I check which is my concave on my left and on my right? So I'm gonna draw an interval table. So I'm going to see from negative infinity to 1, what is it going to be? At x is equal to 1, what is it going to be? And from 1 to positive infinity, what's it going to be? So I can simply do that by plugging in a number that's smaller than 1 into 6x minus 6. So if I plug in 0, for example, I get 6x minus 6, which gives me negative 6. So I have a negative value. This tells me I have a concave down when x is from negative infinity to 1. Right? When x is equal to 0, it's 0. So x is equal to 1, I have 0 because it's an inflection point. Right? So I don't really have a concavity there because I'm changing concavity. So then I can go ahead and find when it's greater than 1. So I can plug in 2, for example. So I get 6 times 2 minus 6. So I have 6, which is a positive number, which means I have a concave up. So this tells me I can describe my critical points using these intervals. So my critical points, well, if I look back, it's 3 and negative 1. So x is equal to 3 and x is equal to negative 1. So if I evaluate those points on this table, 3 is greater than 1, so it's always going to be concave up. And negative 1 is less than 1, so it's always going to be concave down. If we look back at what each of these mean, if it's concave up, that means it's always going to be opening upwards. If it's concave down, my curve will be opening downwards. That tells me if it's concave down and I have a critical point at negative 1, it's always going to be a maximum. And then if I have a concave up, that means I have a minimum. So if I know all this, I can sketch a general function that describes these values. So at 1, I have a point of inflection. At x is equal to 3, I have a minimum, and x is equal to negative 1, I have a maximum. Right? So I can find what those values are by plugging it into my original function. So I can plug in 1, a negative 1, and 3. So that's going to be 15, and if I plug 3 in, it should give me negative 17. So this is going to be negative 1 will be 15, let's say this is 15, and at 3 it'll be negative 17. So my points will be over here, and then I can find where my inflection point is, which is f at 1. Right. If I plug in 1 into my original function again, I should just get 1 minus 3 minus 9 plus 10. So 1 minus 3 minus 9 plus 10. So that's going to be 2, this is going to be negative 1. So it should be somewhere around here. and my end behavior. So I know what my end behaviors are based on the degree of my function. So my original function, again, if I look back, is a cubic function. Right? A cubic is an odd degree, which means I have a positive infinity end behavior as my x goes towards positive infinity, and as x goes towards negative infinity, my y again goes towards negative infinity. So if I connect all the dots, I should get something that's similar to this, where when x is equal to 1, it's an inflection point, so it goes from going from concave down to concave up, and I have a local minimum at x is equal to 3, and a local maximum at x is equal to -1. Right? They're locals because I have values that are bigger than my local maximum, and I have values that are smaller than my local minimum. So this is how we use the second derivative to test if I have a local min or max. If I have a concave down, that means I'm opening down, so I should get a local max at that critical point, and if I have a concave up, I should have a local min at that critical point. So that about does it for me today. So thank you for tuning in. Hope this has been helpful. So once again, if you have any math questions, please feel free to send them in. We'll be happy to assist you. So this is T from Ask Zylor, and I'm signing out. Have a good night.